Welcome to the Hunter Report, and I am hot off of an internet troll war of the favorite topic, which is ISO sensitivity. And the real question we're trying to answer is, what's the most light-sensitive camera on the planet, and maybe even figure out why. And the three contenders are the Sony A7S II, the Canon 5D Mark IV, and the Sony A7R II. Now these cameras have a lot of similarities, but they also have a lot of differences. The similarity is that they're all 35mm full frame sensors. So take a look at the camera right here, and you'll see that the sensor size is the same between all three cameras. But that's where the similarities stop. Where these cameras differ is in megapixels. The Sony A7S II only has 12 megapixels. The Canon 5D Mark IV has about 30, and the Sony A7R II has 42 megapixels. So what gives? How do you fit different amount of megapixels into cameras whose frame is the same size? The way you do that is you change the size of the megapixels. Each pixel in the Sony A7S II is 8 microns large, so the pixels are larger. Compare that to the Sony A7R II, and they're approximately 4 microns. So that's how you jam more pixels into the same amount of size. Something has to change. So then there's this myth, which I'm going to debunk, which says that given the same full-frame camera, the same technology, if you take those megapixels, let's say from the 5D Mark IV, which has 30 megapixels, and you scale them down to the same size of the Sony A7S II, that it's going to produce an equal image. Well, let's go ahead, use the handy-dandy tool over here, DP Review, and do just that. Boom. Okay? And look, the images are clearly different. Here's the Mark IV, lots of noise. Here's the Sony A7S II, less noise. Here's the Sony A7R II, lots of noise. And just forget about the Sony A7 II, because if you see, we're at 102, 102, 102, and here we're at 25, because the Sony A7 II doesn't even go to 102.4. So I'm saying that the simplest explanation tends to be the right explanation. And the fact that the pixel size is larger on the Sony A7S II is the most obvious explanation to me as to why there is less noise. Now, whoever I was arguing with on the internet just wouldn't give up. I don't care that the 5D Mark IV doesn't go up to 102/400. Yes, the listed native ISO range, the max ISO for the 5D Mark IV is only 3200. And that's the point right there. The Sony A7S II has a higher threshold because its larger pixels allow you to gather more light. So, for those of you who are refusing to give up on this debate, let's take it from 102/400, where the Sony A7S II clearly outperforms the 5D Mark IV, okay? And it's just a number. The pictures tell all. The pictures provide thousands of words more than the numbers and the words that are coming out of my mouth. But let's just go down within the native ISO range of both cameras. Here we are, 25/600, and I've purposely selected a place in the image where the light shows a difference. And you can see more noise here, less noise here. More noise on the 5D Mark IV, less noise on the Sony A7S II within the native ISO range. The picture proves it. I'm sorry if I'm coming off as a rant. Explanations out of context do not stand against the visual proof that I'm providing right here. Now, I do wish that I had all of these cameras in the studio of the Hunter Report, and hopefully one day I will get there. So please subscribe, please give me thumbs up, check the description below if any of these cameras pique your fancy. This is the Hunter Report, and I will see you soon.